Okay, let's look at the formation of Lewis dot structures. So Lewis dot structures are usually 2 marks to 4 marks. Here they're 3 marks in this question. It says magnesium and chlorine react to form compound magnesium chloride. Define the term compound. Okay, so you must just know your definitions. Write down the name of the group to which magnesium belongs. You know magnesium's a metal. It's an alkali earth metal. Now it says to you, write down the valency of a chlorine atom. So valency ties into Lewis dot diagrams. The two are linked, okay? And one of the reasons for the old numbering on the periodic table, if you look here, can you see this old numbering on the periodic table? The old numbering on the periodic table actually refers partially to the valency of atoms. Valency is how many electrons are in your outermost shell, not the outermost orbital, but the outermost shell. So for chlorine, here is chlorine over here. Chlorine is in the old numbering, number 7. So the valency of the chlorine atom is 7. And it's these 7 valence electrons that we will use to form a Lewis dot diagram, okay? If you wanted to check it out, you can check chlorine is 17. Okay, now this is not answering the question. This is just telling you how if you don't use the old numbering, you figure out the valency. Chlorine is 17, so it's 1s2, 2s2, 2p6. That is now, if you count them, 10 electrons. Then it's 3s2, that's 12 electrons, 3p5, okay? And that will give you 17 electrons. Now there are 5 electrons in the p orbital, but altogether, can you see everything from here? There's the 1 shell, here's 1s, here's 2s, here is 3s. Here is the 3 orbital, and there are altogether 7 electrons in there, so chlorine has a valency of 7. Now, it says to you, use a Lewis dot diagram to show the formation of magnesium chloride. It doesn't say show what magnesium chloride looks like, it says show the formation. So if you want to show the formation, you need to go from reactants to products. So fairly obviously, we're going to start with magnesium and chlorine. So if we look here, where is magnesium? Magnesium's over here in the periodic table, and it is in column 2. It has a valency of 2. So when we draw magnesium, the element, we would draw it in a Lewis dot diagram with 2 electrons like this in its outermost shell. Now sometimes they put the 2 electrons like that, and sometimes they put the 2 electrons like that. There are slightly different ways to do it according to which book you read, but definitely you must show somewhere that there are 2 electrons. So for now I'm going to leave them there. And now magnesium's going to bond with chlorine. Okay, so first of all, obviously you understand that when you are making a Lewis dot diagram for an element, you have to write the letters for the element, and that symbolizes the core of the element. So when we're having a reaction, we usually have 2 elements, so then we draw one with the crosses and one with the dots. So I've chosen to draw magnesium with the dots. I'm going to draw chlorine with the dots. So chlorine has a valence of 7, which we know from here and from the table. So we start 2, 4, 6, 7, okay? So usually if you don't have 7 electrons, if you've got like say 5 electrons, you go around 1, 2, 3, 4 and pair up the 5th one, because the electrons like to be in pairs. So this is magnesium and chlorine, okay? But they are going to make magnesium chloride. So it wants the formation, it wants the reaction. We know that all atoms like to have a full shell, okay? So for magnesium to go to have a full shell, magnesium loses 2 electrons, okay? So magnesium minus 2 electrons, it becomes Mg2+, okay? So if I take 2 electrons away, they usually like to show it like this, Mg, and then it goes to the ion Mg2+. Now it's an ion, it has to have a charge plus 2 electrons. The chlorine does this. Chlorine does not want to lose electrons. Chlorine wants to gain electrons. So chlorine starts out with its 7 electrons in its outer shell, and it gains an electron and it forms the chloride ion. Okay, and because it's going to get its electron from magnesium, we usually draw the last electron as a dot. And now this whole thing has a negative charge, so we like to put it in a little box and show the charge on the outside. But as you know, if magnesium is 2 plus and chlorine is 1 minus, we need 2 of these. Okay, so you can show this by saying 2 of these. Let's just rub out the plus and then put it closer. 2 chlorines plus 2 electrons is going to go to 2 chloride ions. Okay, so you usually do this, show the magnesium going to the magnesium ion and the chlorine going to the chloride ion, and then you show your final product. Okay, so it's this plus this, and obviously you would write it more across your page because you've got more space. And then you can either pick, if you've got a covalent compound, you put a central atom, but because magnesium is ionic, I'm more inclined to go Mg2 plus. There are absolutely no electrons in the magnesium's valence shell. They are now all core electrons, and that's how come magnesium is happy. And then you are going to have 2 chloride ions bonded to this magnesium ion. So make sure with the dot you show that it gained an electron, and you can put a 2 over there to show it is MgCl2. Okay, so that is how you draw the Lewis dot for magnesium chloride. So other questions that have come up, this was the 1 year's question. The next year's question is show the Lewis structure for the water molecule. So now this one is not asking you to show the formation, it just wants you to show you the Lewis structure for the water molecule. So here's hydrogen with its whole 1 electron, and here is oxygen with its 8 electrons. But if we go up here, we know oxygen has got 6 valence electrons. So now hydrogen can never be in the middle of a molecule because it can only take 2 electrons total in its shell. So it's always hanging around the edges. So anything with a hydrogen, the hydrogen's hanging around the edges. So my central molecule is going to be oxygen. Okay, my central atom. So oxygen has got 6 valence electrons. So then you go around 1, 2, 3, 4, 5, 6. Okay, so usually you put 4 electrons and then start pairing up around the outside. And then along is going to come hydrogen. I'm going to use another color for hydrogen. Hydrogen is going to come and bond here, and hydrogen has a whole 1 electron, so you show it over there. And you know water is H2O, so we need another hydrogen. So on one of the other quarters, because if you put these things in 4 pairs, so 4 by 2 electrons, they sort of make a T shape, like a cross shape like this across your central atom. So then these 2 will end up on the one on the left side and the one on the downside. Okay, so like west and south. That's how you put them in. And so now that is the water molecule. And if you count, everybody's happy because hydrogen has 2 electrons to fill a shell and oxygen has 8 to fill its shell. So oxygen's got 6 of its own plus the 2 hydrogen ones. The shell is full, it is happy. Okay, let me show you the other questions from other years. It says to you here's from another question, and they're using chlorine again. Remember, chlorine had a valence of 7. So it asks you again, how many valence electrons are there? There are 7. The type of bonding, it is covalent. Now it asks you the Lewis structure for the chlorine molecule. So the chlorine molecule is Cl2. So we draw the Cl for the central atom, and we come with chlorine's 7 valence electrons. Remember, you find the valence electrons either from knowing the trick for the periodic table, or you go 1s2, 2s2, 2p6. Okay, so here is the other chlorine, and then you put this extra electron from the second chlorine in between the 2, and because they're between the Cl and the Cl, over here, these two here are showing that they are bonded. And now because it is, they're both chlorines, then you don't normally show one as dots and crosses, but I have also seen it be acceptable to do this with your chlorine. Okay, there's my first chlorine atom, there's my second chlorine atom, and then you go and do the dots in sets of 2 around the atom like that. Then it says to you in another question from another year, it says to you, use Lewis structures to show the formation of substance B, and substance B was sodium chloride crystals. So we know this is an ionic compound, okay, and we know if you want to show the formation, we have to start with sodium and with chlorine, okay, and because it's a Lewis dot thing, they don't always want you to use the Cl2, which is, you know, chlorine's a diatomic molecule. So the first thing you have to do is go to your periodic table and figure out how many valence electrons sodium has. And sodium's an alkali metal, so it only has 1. So this is sodium metal with its 1 electron, and this goes to the sodium ion, Na plus, plus an electron. And then the chlorine has a valence of 7, so it's got 2, 4, 6, 7 electrons. And chlorine gains an electron and goes to the chloride ion, okay, and there is my extra electron, and because I've got an extra electron, I now have a charge. So I think they do like you to show that the sodium loses its electron and becomes a sodium ion, and the chlorine gains an electron and becomes the chloride ion, and then these then become Na plus with the charge, and then you put the chlorine also with its charge but with the Lewis dots, and you can see here I've shown with 1 dot that the chlorine has gained an electron from somewhere else, and the charges show you it's ionic, and also by putting the box around the ions it helps show it's ionic. So then we come to the next one again, and it says to you how many valence electrons does the nitrogen atom have. So if you go back to your periodic table, where's the nitrogen atom? Here's the nitrogen atom over here. It has got 5 valence electrons, okay. So it says how many valence electrons does nitrogen have? Draw the Lewis dot diagram for the ammonia molecule. So obviously ammonia is NH3. So we start with the nitrogen in the middle. Okay, I'm going to rub out the NH3 here. Remember I said hydrogen has always got to be on the outside. So we start with the nitrogen and we go 1, 2, 3, 4, 1 electron on each of the 4 sides. And then there comes my 5th electron for the nitrogen. And then I'm going to come with the hydrogen, and I've got 3 hydrogens. So can you see I've got 3 unbonded electrons? So I come here with a hydrogen and I draw a dot to show it's bonded there. I come with another hydrogen and I draw a dot, and I come with a 3rd hydrogen on the 3rd side, and there is my ammonia molecule. And because the electrons are here, they are showing you, they're between the H that you wrote and the N that you wrote, they are showing that there is a bond with a shared electron. Then it says to identify the chemical type of chemical bond in H2O. Well, this is a covalent bond, and to be specific, it's a polar covalent bond, but they only want covalent. Oh, wait, I missed this. It says draw the Lewis dot diagram for the CO2 molecule. Now this one's a little bit trickier, okay, because this one's actually got a double bond, and you have to figure out, if you can't remember, that it's got a double bond. So we've done this other one that was the Lewis dot formation of sodium chloride. Can you see that's been repeated in a couple of years? And it's this one over here, okay. But I wanted to say to you, let's go and have a look at the Lewis dot diagram for the CO2 molecule. So if we have a look, we've got carbon and oxygen. So if we look at our periodic table here, can you see here is carbon has a valence of 4, and we agreed that oxygen has got a valence of 6. Okay, so the carbon is going to go in the middle, and in grade 11 we'll discuss more how this works out. But the carbon has got a valence of 4 and the oxygen has got a valence of 6. So if we start with drawing the carbon, and we draw the carbon's electrons, carbon's 1, 2, 3, 4 electrons, 1 on each corner, okay? And then we come with the oxygen, and if we drew an oxygen by itself, it would be 2, 4, 5, 6. Okay, there are my 6 valence electrons there. So obviously the oxygen is going to want to share one of these electrons over here. So if I come and I put my oxygen over here and I put a dot, okay, and I draw the rest of the dots in. Can you see here 2, 4, 6, 7 electrons? There are only 7 electrons with this oxygen, and at the moment the carbon's got 1, 2, 3, 4, 5. Okay, so if we come in and draw the other oxygen, and I draw in the oxygen with the 6, 1, 2, 3, 4, 5, 6. Okay, can you see with the single bond the oxygen's got 1, 2, 3, 4, 5, 6, 7 electrons. The other oxygen's also got 7 electrons, and the carbon has got 1, 2, 3, 4, 5, 6 electrons. So at this moment, absolutely nobody is happy because everybody wants to have 8 electrons or to convince themselves they've got 8 electrons. So what happens here is this electron that I've just rubbed out from carbon rotates itself into the bond as well, and then this electron from the oxygen is also going to rotate itself into the bond here. So this is a double bond. There are 2 pairs of electrons here. And so now if you look on this left hand oxygen, I've got 1, 2, 3, 4, 5, 6, 7, 8. So now this oxygen on the left is happy, and we're going to do exactly the same thing on the right. This carbon had a second unpaired electron. It has to rotate into the bond, okay? And then this other electron from the oxygen out here, this one over here, let me rub him out here quickly. He is going to also rotate into the bond over there. And so if you count now, you've got 2, 4, 6, 8 electrons on the left and 2, 4, 6, 8 electrons on the right. So let me draw this for you more neatly. The carbon is putting 2 of its electrons into the bond, and the oxygen is putting 2 of its electrons into the bond, okay, on both sides. And the way you figure this out is when you start matching up the electrons, all of a sudden you notice like nobody's happy because not everybody's got 8 electrons. So you start rotating electron pairs into the bond, and then you end up with the CO2 structure where if we were to draw it with the Cooper diagram, it's C double bond O, C double bond O. And that's how it works with the Lewis dot structure for the carbon dioxide. And these are all the Lewis dot structures for the last 3 or 4 years of past paper grade 10 papers. You will draw Lewis structures in grade 11 as well.